Hi, welcome back to the breadboard. Over the last few weeks I've been putting together a beginnings of a new series to present to you on my channel, and with assistance from RS Components in the UK, I'm going to take you through the world of automation, not just industrial automation but home automation, building automation as well. This video is going to introduce to you some of the concept and a little bit of history very briefly of that, and then I'm going to break it into two main streams. One is home automation and one is industrial automation. There's going to be some overlap between the two because it's inevitable. The lower end of industrial automation has now really flowed into the home automation market, more at the upper side of it than the lower side, but nevertheless it's flowed into the home automation as well. And when we start looking at home automation things, I'm not going to be looking at what you can buy off the shelf at your local hardware store. They're either very, very expensive or they're quite proprietary. What I want to show you how to do is to design and build your own home automation devices, and from that end it's going to be based around things like Raspberry Pis, Arduino Unos, TI Launchpads, and maybe some custom electronics driving fans, measuring temperatures, humidity, barometric pressure, and a whole bunch of things like that. On the industrial side, we're going to do similar things, only where I can, I will use proper industrial PLCs. So some of these are going to be from Crozet, some of them are going to be industrial shields, some maybe from Siemens with some of the devices. It just depends on what is available to me as we go through the concepts, and I'll either be doing online, basically just taking you through some concepts on the computer, or where I can, we'll be doing some very, very practical examples of how to put something together. One of the other things we're going to look at is really how to make all of these things communicate as well, because one of the biggest things I've seen when I've been looking online in the various communities is a lot of confusion or home-baked ideas about how to make your Raspberry Pi talk to your Arduinos or to each other, and how to make all of these different things in the home communicate with each other. And a lot of people are building and designing their own proprietary protocols to do this. Now you've got things like, you know, Bluetooth and Wi-Fi and everything else, and that's not the kind of thing I'm talking about. What I'm talking about is things like XB protocol, and there's so many different home automation protocols that are not compatible with each other. It's even started a new market in having a bridge that effectively tries to couple all of them together and give you a common interface. So what I'm going to do is show you how to take some of the standard industrial protocols, primarily ModBus, and use them either in the home or in an industrial setting to make all of these things talk to each other in a well-established but relatively simple way. And we're going to do that over Wi-Fi, over serial, over hardwired Ethernet, and a bunch of things like that. Anyway, I have a short presentation to go through. I've just been putting a bunch of things on PowerPoint slides. So I'm just going to switch to the computer and we'll go through that, and then that'll end the introduction to the home automation. And then I will break into the separate streams and start taking you through what constitutes home automation versus industrial, with some practical examples and things like that. And we'll slowly build up more and more examples and more elaborate systems that you can actually take the learning from those videos and apply them to your own solutions that you may have at work or at home. Either way, they should be cross-compatible with each other and work quite well. Obviously, you can go way more expensive. We're trying to keep this to something that you can do yourself, as opposed to buying a solution off the shelf for absolutely everything. And that's what I intend to do, is show you how to do low cost but reliable and relatively straightforward to implement solutions that you can use either in the home or at work in an industrial setting or an office space. So let's get to the computer. First of all, I just wanted to say that this presentation would not be possible, or the whole series would not be possible, without the help from RS Components, who have been kind enough to provide many of the products and parts that I'm going to use to demonstrate the principles and actual practical examples of how to make things work as we go through this. So thanks very much, RS Components. steps towards automation and the Internet of Things. Ultimately, with automation, the current buzzword around the Internet and the engineering world is the Internet of Things. But where does that all come from? All right, so if you go back a long, long time, maybe the 1900s and before that, pretty much everything was manual. Then we went through the evolution to being mechanization, the Industrial Revolution, things like that, towards automation. And computers came along over the last few years, got into the Internet of Things. We're going to go through here on this presentation and discuss a few of these. So going back, what is the definition of manual labor? Well, working largely or exclusively by hand or with animals. So we've got a few examples here. It was all the energy used to actually create some kind of product or do some kind of operation was all with muscle power, human or animal muscle power. So the Industrial Revolution came along, we started to introduce power into those things. We mechanized things. So there's still a lot of manual operation, but the grunt of the hard work is done for you. And here's where we start to get a little bit of home mechanization as well. I've just thrown in here a thermostat that shows you the humidity on the bottom and a temperature on the top. It's not fully automatic, and it would just turn on and off the boiler, and that's all it would do. And it would do that day or night. There's no, between 7 o'clock in the morning, 7 o'clock at night, or anything like that. If you turn the boiler on, the thermostat will just keep it at that temperature. Very crude, just simple on-off control. That's mechanization. It's basically taking the process of the manual job, doing what you did, and then doing it with some kind of machinery, whether that's electrical, pneumatic, hydraulic, or whatever it might be. What do we get when we start looking at automation? Well, on the left here we've got like a packaging machine. It's fully automated, just your packages come in one side, it's got a big roll of labels and stuff like that, and it just puts labels on machinery. In the farming industry, you've got great big huge watering contraptions that automatically at certain times of the day will turn on, and they will make sure that the fields are properly irrigated and everything else. On the right here we have an example of the evolution of the home thermostat, where you've still got your thermostat on the right hand side here, but on the left there's now a mechanical clock, and it can turn the heating on and off at specific times of the day and for specific durations, and it just does it. It doesn't have a concept of weekends or weekdays. It's just the 24-hour clock. Still very, very basic compared to a lot of today's things, but this is just an evolution where we go to a certain level of automation. So you can see here on the lathe at the bottom that you've got additional screws and things like that. And some of the automation that's been added to a device like this is the ability to automatically cut threads or to automatically turn a piece of metal within certain limits without human intervention. The human would set it up, hit a couple of levers, and then through things like cams and various other control devices, it would do a certain level of automatic, but basically a repeatable process on the piece of metal. And then after that, with more innovation in the sort of like 80s, 90s, and towards now, we start getting computers and everything else, which is where we now start to computerize, where we actually go to numeric control and everything. And I actually pulled from Wikipedia here an example of the definition. So it's the automation of machine tools or equipment that is operated by precisely programmed commands encoded on a storage medium, as opposed to controlled manually or by hand, wheels, levers, or mechanically automated by cams and things. So all of the previous examples have been everything that this describes here as the opposed to. And what we're adding is programmability. We're adding the ability to have the operations changed by software or at least program changes. It's not just a mechanical lever that once it's set up, that's it. It can do the same thing. In this case, we're introducing the concept that by changing some software or some programming, you're able to get the devices to do something different. It's not just every 24 hours it's doing the exact same thing. And right now, if you look out on, whether you Google it or just look in the local hardware store about home automation devices, you're going to see so many different things out there. The variations in the systems, the protocols, the interfaces, they make it very difficult for you to pick a light bulb from one brand and a thermostat from another one, like the Philips Hue lights and the Nest thermostats, and maybe a Honeywell furnace controller and some other device and make them all work together. There's a lot of them. They're very confusing, and it's very difficult for a home non-technical person to be able to put all of this together and actually make something working, which means it still keeps it relatively expensive because of that fact. You have to hire somebody that knows what they're doing as opposed to trying to do it yourself. It's very easy to go to your hardware store and pick up a few plug-in lamps, for instance, with a little remote control, because you're not having to set anything up. But the minute you want to make all of these, your light controls, your power, heating, ventilation, monitoring your outside temperature, your sprinklers, you want to make all that work together and have it all on your one application on your smartphone or something, then it becomes much, much more difficult. But if you are technically savvy, then there are a lot of ways that you can do this relatively inexpensively and make it all nicely work and integrate, even if there is a diverse set of base products that you're using. A coffee machine is an example of a CNC. It makes you coffee. All you do is you provide it the raw materials, water and coffee, and you hit a button. It sucks in the water, it heats the water, it puts it through a pressure container that's got the coffee in it and spouts it into a jug or a mug or something like that. It does it all automatically, gets to the right temperature, sets the right amount of water through it, and everything else. Your toaster or a Roomba that runs around the floor doing your vacuuming, that's another example of a CNC. It doesn't have to be a big industrial thing to be classified as a CNC. You've got industrial controls, and often when you hear the word CNC, it refers to industrial devices. But technically speaking, a CNC doesn't have to be. Now, going on from there, let's just look specifically at something like industrial automation. One of the biggest things you've seen is on the right hand side here, that you see a lot on the TV and everywhere else, is making cars. Car manufacturing was one of the primary places where industrial automation and specifically robots started to really take off. As we come across here, you've got things like very complicated CNC machines. So before we looked at various hand tools or power tools, but now when we get into some of the more modern CNCs, it's fully automated and articulated. It's basically taking a robot arm and putting a router or milling bits on the end of it, and it can pretty much carve out of metal, plastics, wood, pretty much anything you like, any shape you like. This is an image of a fully automated tractor that's got GPS tracking, and it can basically run around a field and plow or sow or various other things completely without the driver in it. All right, it uses the computer-controlled steering, and it has strategically placed. It's got GPS, but also it would have additional boundary markers around a massive big field, and it just gets on with it without the driver having to actually be in there. The primary result of all of these slides that I have on the screen right now is that your efficiency, your quality control, your repeatability, which means at the end of the day it's the cost has come down massively. You can do so much more with so little or so less time and energy as what you could do before, because of the mechanization followed by automation followed by computerization, programmability of the operations. Energy efficiency in industry has become a high priority. Electricity is expensive, space is expensive, keeping things cool like factories with people in is expensive. So all of these things, the cost can be reduced now because you've got far more efficient processes. There's a lot of work going into making even robots far more efficient by minimizing the amount of movement they have to do for their operations to get from position A to position B. Now in the home automation, right, now I'm showing you some examples here. There is a little bit of an overlap, which we're going to see shortly, but with home automation, you're seeing things like Nest, smart devices, tablets being used as an interface for the humans. All right, the thermostat has become far more complicated. All of these devices on this screen are all examples of things that you can do in the home very easily. All right. One of the things with home automation that people like to do is to be able to do operations remotely. So here's an example. This is actually a screenshot from my very own cell phone. All right, showing an application which I'm going to introduce it to you when we start going through the home automation, that allows you to remotely monitor and control your home devices. It's all about labor saving, so your washing machines and stuff like that. There's even the home manufacturing now. These two right-hand things are actually two products that I own. Well, this one is a 3D printer, and I have one of these, and that's great for doing small home manufacturing of various parts, either for repairs or just to make toys or to make and help with boxes for projects and things. This second box here is a CNC. Now, I built this. This is one of the things that RS Components sponsored me with, to show you how to build and perform a bunch of automation, and what I chose was to do a CNC as the platform to demonstrate all of that. But this is something now that is well within the reach. Now, this one is fairly big, but you can make them a lot smaller just to do PCBs or small bits of work, but economically within the reach of an average homeowner these days. And as we go across here, you know, most of you are going to recognize these things on the left-hand side. You know, coded door locks, the thermostats, the tablet for home automation. Automating something doesn't mean it's the Internet of Things. Now, one of the primary definitions of the Internet of Things is that the device is networked. It does not mean it's actually on the Internet as such. It can be, but the primary thing is it is networked. They support remote control and data transfers. Hardware devices can include sensors like cameras and thermometers, controls, actuators, things that do stuff for you, and communication systems. Remote control can range from a simple infrared remote control, for instance, that you use for your TV. You can these days also get plenty of applications now for smartphones, and we're going to be demonstrating, or you're going to be seeing some of these examples as we go through this set of presentations. The price has come so low now that it is cost effective for the home. So that's home automation, and as I say, we're going to go into lots of examples of that as we go through these presentations. So then, what products can form the basis of industrial automation systems? Now, there's a lot of things on this slide, and there's very little words, but I wanted to show you some examples of the things that would really constitute home automation. And on the higher end, we've got things like industrial cameras for vision sensing. We've got a whole bunch of sensors here, like level sensors, float sensors, humidity, light. You've got actuators. These are all examples of industrial actuators. Pressure control, solenoids, flow meters, pressure sensors. You've got programmable logic controllers. This is an example of a Siemens industrial controller. There are so many to pick. I don't have one of these physically, but nevertheless, you can actually buy them from RS Components. These top two examples are an example where at the lower end of the industrial environment, you've got these industrial shields from a company in Spain that produce these, and these are certified in Europe for use in industrial environments. They work on the standard industrial 24 volts DC, and then as we move to the right hand side, these are also parts that can be used in an industrial environment but also can be used in a home environment. So there's a little bit of an overlap. You've got things like the Raspberry Pi, and I have a device which we're going to look at, from another one from Industrial Shields, which is a 10-inch touch HMI, human machine interface, that is actually uses a Raspberry Pi as its controller. So it's got a touch screen, HDMI output goes to the screen, so you've got high resolution touch interaction, and you can basically put whatever program you want. So the possibilities are vast as far as, it's limited to your imagination. Here's some other examples where you can just use touch screens. This is actually looking at the official 7-inch Raspberry Pi LCD as opposed to the 10-inch one that's on the Industrial Shields device. You've got smartphones where you can remotely monitor the factory or the sensors and everything else in your industrial environment. Up the top right hand corner here is just a couple of examples of sensors that can be connected to some of these industrial controllers. Now, all of these you will find in various industrial control systems. In fact, this particular temperature sensor you will often find in a package like these ones over here on the industrial setting, where it's actually buried in a stainless steel tube so that you can actually use it in a harsh environment without exposing the actual packaging of the chip. Right? Then you've got to pick the right things for the right job. And when it comes to medical and automotive, there are a lot more regulations about what devices you can use for that, and they have to be certified for that environment if you're going to put it into a product that's going to be sold or used, and put out there in the wilds. It's one thing building something for yourself and taking the risks for yourself. It's another thing when you're building products out there that you're going to make out as a product. They need to be certified and they need to be suitable for the job. Anyway, that's industrial automation. So let's go look at the home automation. Right off the bat, you're going to notice here that there is a little bit of an overlap. All right, and there's some devices here that are included that could easily have been on the other page as well. So you've still got your Raspberry Pis, your Arduino Unos, your Arduino Megas, your Ethernet adapters. I've also included some of TI's products here with the Launchpad and some of their little control panels and booster packs that go on a Launchpad. And the reason these are here is not because they're not usable for industrial automation as well. They can be. The chips certainly can be. And with the right packaging and everything else, then all of these are usable in an industrial as well as a domestic. The point about these being on the home automation is that they're not expensive. All of these, probably the most expensive single devices on this page would be the larger of the industrial shields programmable logic controllers kind of range. But things like the Arduino Unos, the Raspberry Pis, about $40. All of these Launchpads and Arduinos, they can be had for $10 or more. They're very, very inexpensive. This Sonoff mains controller, I've done so many videos and commented in so many communities where people have tried to build and do their own mains controller, and a lot of times they've just been lethal. All of the safety, this is completely encapsulated in a plastic container. It's got cable clamping. You've got your mains out to your device, you've got your mains in, and there's no exposure once this thing is put back together, and you can remote control it from any of these other devices just over the Wi-Fi. So it's really easy to do and very, very safe, which is why I've included it in here. Same touch panel displays, same smartphone applications, same home automation using next-gen displays and ESP Wi-Fi modules. These sensors, you can buy them from RS Components, you can get them from eBay, you can get them from all over the place. They're inexpensive, so you can equally use them for home automation, sensing a temperature in every single room of the house, outside, sensing the humidity in the house and outside, controlling it. All easily doable with just the kind of things that you can see on this page. All right, now I have deliberately not talked about protocols and everything else in here because that's just a whole nother subject of its own, and you don't have to use the well-established protocols if you don't want to, but we will build up to it, and I will show you some examples of where we are doing that. But anyway, for now I'm not really going to talk about it too much. Anyway, so where do you go from here? We've looked at everything from manual processes right up to home and industrial automation, where you've got computers and everything else. Well, the next big thing and the current big thing is Internet of Things. So we go here, and what is the definition? Now I've taken this again from Wikipedia. The Internet of Things is the network of physical objects, devices, vehicles, buildings, appliances, and other items, embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange data. It says nothing about the fact that they have to be on the Internet, although it's kind of implied by the Internet of Things. But it doesn't say that they're even automation. All right? An IoT device does not have to be an automated device. It has to have enough savvies that it can collect some data and it can exchange data with some other network connected device. Now that networking can be Wi-Fi, it could be some other of the numerous wireless, 400 megahertz, 1.1 gigahertz, 2.5 gigahertz, whatever you like. But it's able to communicate with other devices and exchange data. That's one of the primary things that is here. And it doesn't mean that the device is sending data out to the cloud, in quotes, or it's sharing data to anyone on the Internet. By definition, all of the IoT devices have to be networked, as based on the quote of what is the definition of Internet of Things. But it doesn't mean that it's on the Internet. And why is that so? Why am I saying that? Well, if you think about it, any product out there, whether it's monitoring of vehicles or some other sprinkler systems, vendor A makes a whole nice automated sprinkler system for your home. He doesn't want vendor B coming in and putting his controller on vendor A's devices and vice versa. So they end up making them proprietary and keep them a secret. That doesn't mean that they're not communicating back to a central control system and maybe even out to the vendor for maintenance and warranty work and things like that. But it doesn't mean that they're sharing it with everybody else in the world either. And I think you'll find when you take a very pragmatic view of it that in most cases things that are actually IoT devices are not public. They're not being shared and available to anybody. Now there are some examples where it makes sense to be just who cares who sees it. All right, weather stations. All right, you can have some weather stations in your home or around your home that can share the information. Traffic flows. Right, these ones make sense to be completely open, completely public, where anybody can monitor it, so that GPS navigation, sprinkler systems, and all sorts of other things can take the data that's being made publicly available and can make intelligent decisions about what it's going to do for either its vehicle navigation or, do I water the lawn today because the weather says it's going to rain later. So maybe I'll hold off and wait and see what happens. So it's not the fact that everything is public and in the cloud for everybody to use. It's the fact that they're networked. And lastly, just because a device is classified as an IoT device doesn't mean it's automated. I said that a moment ago. It could be very clever, but it could simply be collecting a sensed temperature or a switch position, but it can't do anything about it. It doesn't have any control capability. It's just saying, oh, it's warm today, I'll let everybody know it's warm. Or it's cold today, I'm going to let everybody know it's cold. And that's all it does. All right? It can be very sophisticated too. It can be a complete automated system that is sharing its control information, and maybe it's using MQTT, which is a protocol for packet data sharing. Very simple. We'll get into that in another video as well. But it's a messaging based system that allows a lot of IoT devices to easily communicate into a central repository. But that doesn't mean it's a public repository on the internet, like in some of the examples I'm going to show you when we go through some practical examples of home automation, industrial automation. I will be using MQTT, but it's going to be running in my local environment, and I can actually select what information I share and what I don't share. So if you've got a home automation system that is measuring the temperature outside and inside your house, turning lights on and off and all sorts of other things, you may be quite happy to let anybody in the world know what the temperature's like outside, because who cares? But you may not be so happy about sharing the fact that all of your doors are unlocked and nobody's home. All right? Or letting people see the lighting or heating programming stats that you're using, because it could give them an indication of when you're not at home too. So it can increase the chances of you being burgled. Kind of social engineering the data to figure out when the best time is to come and rob you or whatever. All right. So that's one of the reasons why people don't want to share everything. Now, a lot of issues around the Internet of Things right now is to do with security. A lot of it is security through obscurity, in that there is no security, but because they don't advertise what the connection points are, they just hope nobody's going to find it. And they make it a little bit convoluted as far as how things work, and hope that, without sniffing the local network and things, they probably won't figure out how it works. But if somebody knows what kind of device it is, then perhaps they will be able to figure it out, because maybe they'll go buy one and now they know, and now they can start hacking into things. One of the things with home automation too is you don't want somebody coming into, remotely to your house and starting turning all of your stuff on and off. That's why you really want to have it secure. You may, there's so many devices, like Nest is an example with their devices, where you can buy these things, you put them in the home, and yeah, you can access them through your smartphone and everything else. But if you want it all to operate in an automatic fashion like that, you have to use the internet-based servers. Now, not everybody can necessarily get to your data, but what happens if the company that is providing that internet service goes belly up? All these products in your home are now useless, right? They might work standalone just as a smoke detector now, instead of the full automated Nest smoke alarm thing. But you're no longer able to control it with your smartphone or whatever else. And this could be a thermostat, it could be smoke detectors, it can be something that's controlling your garden watering system. If it relies on a remote server and service to operate, then really, in my book, it really shouldn't be going into the home. And what I'm going to show you is a way, in all of the examples I'm going to do, is a way of doing it so that it is not in the home. Sorry, where it is in the home, it's automatic in the home, and you have a choice of whether you make it remotely available. But if you don't have that internet connection, there's still IoT devices, there's still network, they're still communicating with each other. It is just constrained to within your local network in your home, your office, your industrial factory, or whatever it may be. You know, and obviously factory automation, they may have IoT devices there too, but they don't necessarily want to share it with everybody. They may want to keep it proprietary. They don't want to know how much electricity is being used on a certain operation or various other things. You know, it can cause all sorts of issues in some cases. All right. So what's next? So I'm going to be doing a series of videos and blog posts with downloadable content. So everything I show you how to do, where there's code that I've written or that I found, I will either provide links or upload it so that you can get it yourself and replicate the examples or modify it to do whatever you want. I make no warranty, and I'm not necessarily trying to make final products here. I'm showing you how to do things. I will separate the industrial and the home automation into separate topic threads, even though, as you've seen through this presentation, there is an overlap. All right, especially between the low end of industrial and the high end of home automation. On the home automation front, there's going to be much more of how can I do it myself, all right, using Arduinos, Raspberry Pis, TL Launchpads, and the like. For industrial automation, as I've already said, I've got a bunch of products that RS Components have been kind enough to send me to help with this, and I will be showing you how to program them. And in some cases, a lot of these are low enough cost that if you're doing a significant home automation project, they are perfectly viable for their home use as well as an industrial use. And I'm going to try and use open standards where possible. So that means Ethernet, not something like XB or one of these other ones that really are proprietary or they have a cost associated with getting into them. I want to use things like ModBus or standard, just Ethernet with basic protocols, MQTT and stuff like that, and use open source hardware as well and software. So Visual Studio 2015 Community Edition, for example, or on the Raspberry Pi using Node-RED and JavaScripting and everything else. So as far as the software is concerned, everything I'm going to be using is going to be free to download. Even with the industrial controllers, the software that I'm going to use, whether it be the Industrial Shields or whether it be a Crozet HMI, the software that you use to program them is free to download and to use. So that's the way I'm going to be approaching this. Anyway, that's the introduction to all of this is done. So the next thing I'm going to do is start breaking into some automation. I'm going to do a quick video on showing you some of the devices and what they can do. And I'm going to start with a lower end sort of industrial control example and introduce one of the protocols that I'm going to be using for everything. And then I'm going to start looking at some bare board Arduinos and Raspberry Pis and things like that to control motors, measure temperatures, and go into details of how each of these work. The first video is I'm going to be measuring temperatures and everything else, but I'm not going to go into the details of how it works. I'm going to be more looking at the how the industrial control or home automation system is put together and how it's communicating with each other and things like that. And then I'm going to break them down into individual parts. So for instance, how do you put on a barometric pressure, humidity and temperature sensors onto an Arduino Uno or a Raspberry Pi or something, and how do you write code to make it all work and do something practical? All right. How do you make your Raspberry Pi, which will set up as a master controller using Node-RED, talk to an Arduino Uno or another Raspberry Pi that's doing some control using an industrial standard protocol like ModBus? All right, that's the kind of thing we're going to be doing. And I've also, as you probably guessed going through the presentation, have a CNC milling machine that I built in my workshop that I have at home here. And there are certain aspects of what that is capable of for the controller, like with Mach 3, that can also communicate with an industrial Shields HMI display or an Arduino Uno and things like that too. So these are all other examples of where we use standard protocols, and in this case Gerbil and again Modbus, to communicate with these other devices to help in the automation of processes. So anyway, I think that's about it for the introduction. I think you got a little bit of a taste of where I'm going with this, where we've come from, where we're going to. So if you have any comments, questions, or suggestions about how, or if there's anything particular you may want to see, or that I might try to demonstrate, as I said, I'm going to use ModBus and various other things, then let me know and I'll look at it, and if it's not going to take inordinate amount of learning curve to figure out, then I'll do my best to include it. And as I say, if there's any particular products, can't guarantee that I will be able to demonstrate them, because if I don't have it and one of my friendly vendors is not able to send me an example of it, then I won't be able to demonstrate it. But I may be able to look online and see how it works and at least provide some suggestions. Anyway, this video has been going on for long enough now, so I will call it quits here, and we'll get this up online, and we'll start getting into the meaty bits of the various control systems and automation. See you next time.